Exponential regression using the TI-84. Sometimes when you're given the table of a function, you are asked to determine if it's exponential. And you can differentiate between something being linear and something being exponential if it has a constant rate of change. For linear, meaning it has a pattern that is adding or subtracting. And something that is exponential has a constant or common ratio where it has a multiplying or sometimes we call it a dividing pattern as you look at how the table is changing. All right, so as we look at our table here and we see a constant increase in x, what is happening with y? Looks like we're adding 3, we're adding 3, we're adding 3. That's a common difference, so this table is linear. Over here on the right, we have a constant increase of 1 in our x, but over here in the y, it looks like we are multiplying by 2. That is a constant ratio, and we call that an exponential function. So let's recap. A linear function will have equal differences, also known as a common difference, and an exponential function will have equal factors, also known as a common ratio. Sometimes when you're given a table, it's difficult to determine using mental math whether it's linear or exponential. Once you have established that there is a common increase between the x values, you can ignore that and look solely at the y's. Now, in order for you to determine if it has a linear pattern or a common difference, you're going to look at the answers in the next positions. I'll call this the A2 position, right? The next position. And you're going to subtract the previous position. So if I start with 120 and I subtract 480, what do I get? So on my calculator, I'm going to type once I find that difference, I do the same thing with the next value. So instead of 120 minus 480, I'm going to do 30 minus 120. And if I get the same difference, then that means I have found the common difference. It's not the same. So therefore, this is not linear. It's not linear. So now what we're going to do, instead of finding the common difference using this formula, we'll look for the common ratio using this technique. So I'm going to take the second value and divide it by the previous. So I'm going to use this feature on my calculator to determine that ratio. So 120 divided by 480, and I get the fraction 1/4. Now I'm going to do the same thing. The next value divided by the previous. So again, I'm going to open my ratio feature here, and I'm going to type 30 divided by 120, and you'll notice I get 1/4 again. So this is exponential because it has a constant ratio. And if you can't figure out the ratio on your own, you use this technique to check the pattern. So you take the next and you divide it by the previous. So the constant ratio is 1/4. We could do the same thing with question 2. To check if it is linear, we will use the next subtract previous, and to check if it's exponential, we will use the next divided by previous. And this is how you can determine whether something is exponential or linear by looking for these patterns. So I do have a consistent pattern here with the x's minusing 3 each time. So now what I'm going to do is take the next number and subtract it from the previous. take the next number and subtract it from the previous. And take the next number and subtract it from the previous. And you'll notice I'm getting a constant value here. So this is linear, and it has a constant or common difference, and that value is -7. Sometimes you are asked to write the equation of a graph or a table, and using your calculator can assist in this process. If I'm given a graph, I can create a table of points by using these perfect corner dots that I see on the graph. Now, even though mentally we may be able to compute the constant ratio here, I'm going to show you how you can use it, how you can use this table in your graphing calculator. So I may notice the pattern here is going down by half every time, but let's say I wasn't noticing that. What I'm going to do is I'm going to type this data into my stat, edit, list 1 and list 2. And then what I'm going to do is I'm going to turn on my diagnostics. And you can do that either by pressing the mode button, arrowing down, and making sure the word stat diagnostics is highlighted in black. Once I do that, I can calculate the regression of this data table by pressing stat, arrowing over to the word calc, and then going all the way down off the screen to number 0 for expreg. I'm choosing exponential regression because I can see that this is a curved line or curved data set here. So expreg, press enter 5 times, and now I can get the equation. So the initial value is 64, which makes sense because it has an x value of 0, has a rate of change of 0.5 or 1/2, which is I see mentally the pattern happening here, and it has a perfect correlation coefficient of -1, which means that there is a negative relationship here. So our initial value is 64. Our rate of decay is 1/2. You can write it as a fraction or you can write it as a decimal. It doesn't matter. And that is how you calculate exponential regression.